Hello class, this is the lecture on growing space and our start to talking about thinning. So this is picking up from where we left off in class. So where our story left off. So we had this stem replacing disturbance. Saplings and seedlings, they were free to grow. There was available growing space. So they were growing, they were uninhibited, they weren't hitting that wall. So if we go back to a previous lecture, go back to that picture I showed you from Oliver and Larson, and there's the tree and there's that kind of line, the wall. And remember, as the tree hit the wall, something changed. Well, what changed? So as these saplings are going to continue to grow, they're going to need more resources. Eventually all the growing space is going to be used, so that all the growing space is going to be tied up by the individuals that are there right now. So what is happening? What is going on between these individuals? They're competing. Competition is happening. So as competition starts occurring, we move to a different stage of stand development, the stem exclusion stage. So we've shifted from stand initiation to stem exclusion. So some of these better individuals are going to start having a competitive advantage and are going to reduce the growth rate of their neighbors or kill them. So what is a better individual? What makes an individual better? So hopefully when you're thinking about this better, you're thinking maybe they're on a better microsite. So maybe they have more access to nutrients or water or whatever. So there's a better site. Maybe they have better genetics, higher growth rate, whatever. Maybe they just started a year or two before the seedling or sapling next to them. So they have an age advantage. So they got a start first. So there's all these aspects that can be called better. But whatever it is, some individuals are going to start growing faster, are going to have this competitive advantage. And those trees that have that reduced growth rate, those individuals that are being killed, this death from suppression, this death from competition is often called natural or self-thinning. So we look at these different crown classes, and this is really where we can see this differentiation. So if these species are all the same individual, we can see we have dominant in the D, and those are trees that are generally receiving light from the top and light from at least 3 of the sides. Whereas our codominant trees, they're still receiving light from the top, and they're probably receiving light from 1 and 2 sides. Whereas our intermediate trees are only receiving light from the top, and our suppressed trees are receiving very little light. This other category is open grown, and we can think of that as something that it's free to grow. It's not interacting with other individuals. So think of kind of oak savanna, those very open oaks. That would be something that's open grown. Or as you walk around campus, any of the trees that are planted on campus, those are open grown trees. So we have our different crown classes, and we can think of these different crown classes. This is a great example to look at this stem exclusion phase. So we see certain individuals are dominant, certain individuals are at a competitive advantage. Other individuals are not at that competitive advantage. They're suppressed. They're not able to take advantage. They have less growing space available to them right now. So stem exclusion, what's happening during stem exclusion? Well, the growing space is fully occupied. Competition is occurring. New stems are prevented from establishing, and some existing stems are being killed. So often stem exclusion, it looks pretty open and kind of park-like. So you don't have a lot of stuff going on in the understory. All that growing space is currently being used by this overstory, by that first cohort. So what happens? Well, we have some existing stems being killed. And this death could be due to competition. It could also be due to disturbance. So something like wind, insects, whatever. Something is going to impact that overstory. And it's no longer going to be this intact overstory. So as some individuals compete, others will continue to expand, but there's also likely going to be changes in the understory. So as we have death in the overstory, we're going to have a little more light. It's also going to be a cooler environment. So there is light coming in, but not the same kind of direct light that we saw after a stand replacing disturbances. So there's probably different herbs, shrubs, and tree species beginning to establish in the understory. And we're moving to another stage of stand development, this understory reinitiation. So pretty much like it sounds, our understory is reinitiating. We're getting new growth, possibly new species. There's opening of growing space. And then our final stage we can transition is to old growth. And stands will continue to develop. Individuals will die, new ones will establish. How do we define old growth? So take a second, think. How do we define old growth? Maybe you have a picture of something from the Pacific Northwest, one of the old growth forests in Washington. Just huge trees, moss, all just very dense, big trees. And that's one example. We can also look at Estevan's Pines Sanctuary in the Upper Peninsula of Michigan, and this is home to one of the oldest stands of virgin white pines in Michigan. So there's a lot of different definitions of what old growth is, and these are just two examples. And the first one is from the Dictionary of Forestry, and it states by saying old growth forests are defined in many ways. And one of the main ways we can characterize old growth forests is based on structural characteristics. So the number of live trees, the canopy conditions, the number of snags, the down logs, and coarse woody debris. So we can define old growth based on structure. So if it fits the structural class, we can call it old growth. Minnesota also has a way of defining old growth forests in Minnesota. So we talked about in a previous lecture, much of Minnesota, much of the lake states had some kind of logging event that occurred by 1910 or after. So a lot of this area was disturbed. So we don't have a lot of true old growth, so that something that predates settlement. How Minnesota DNR defines them is based on these characteristics. So they have to be, some trees have to at least be over 120 years old. And then as we look at it, a lot of this is looking at structure again. So large standing dead trees, so snags, large fallen trees, again, that coarse woody debris. The forest has a mix of age classes. There's small openings and canopy gaps, and there's tip-ups. So we look at this, while yes, there is an age component, a lot of it goes back to structure. So we can define old growth in many different ways, and one of the most common ways is looking at structure. So how does stand development and silviculture, how do they fit together? So we can think of stand development as this base. So stand development is this understanding of how trees grow as both as an individual within a stand and how disturbance influences them, both the individual and the stem. And from this, we can develop silvicultural systems, and it's based on this underlying knowledge of the silvics, the ecology, and the site history. And silviculture can influence the time a stand spends in each stage. So we can reduce it or we can increase it. So for example, silviculture can reduce the time a stand spends in, say, stem exclusion or stand reinitiation. We can push it towards having structural characteristics of old growth. So we can push a stand using silvicultural techniques towards the old growth stage of stand development, so we can reduce time in other stages. We can also increase the time a stand stays in a certain time. So we can use these silvicultural systems to manipulate how a stand develops. So that's the end of this lecture. We'll pick up again in the next flip lecture on thinning. Thanks.